So today I just thought we'd take a look at this Ego 56 volt 21 inch LM2100 mower. In a previous video we did some troubleshooting with this mower. We do believe that this controller is faulty, and these controllers are about $125 or so if you can find them. So I want to try this 60 amp controller. It's a 48 volt 60 amp, and I believe it's going to be a good fit. I don't have it in yet, but this is my first go-to. The 40 amp controller here may work as well, and I actually have this little 30 amp controller, but the thing about this 30 amp controller is it does go to 70 volts, but I just don't think it's going to hold up over time. As we see here, this original Ego controller, the pine on it is so hard, and there is no way to repair this, unfortunately. So I did decide to take my little DC drive out of the housing that came with it. Got it mounted to a piece of Lexan that I have cut to fit this spot. Probably 101 ways to do it. That's just the way I decided to do so. I don't know if I'll keep the variable speed yet or just make it wide open. We'll see how it goes as we start doing some testing. So just drilling a hole here so we can mount this 40 amp relay. We might end up needing some higher quality relays, but this 40 amp relay here has normally open and normally closed, so we should be able to use this for braking and take the load off of our start switch that Ego originally had, taking care of the braking with that normally closed contact. And here I've just attached a jump bin terminal strip to this relay just to make terminations easier. Here I'm just showing that I got the LEDs mounted back on the housing and got the wires routed around, and I've soldered in a JST-SM connector, a 2-pin connector. I just had a bunch of these connectors, so I used them. Just going to mount the terminal strip here to make it fairly accessible. There really wasn't a better place to put it, so just going to mount it right here for now. I can probably get my short screwdriver in there. And here's the push button that I've decided to use for the LED lights. So to keep the LED lights functional, even the green part of the power on and ready LED. I'll talk more about this at the end of the video and share a diagram, but we're going to keep this part coming on green using our blue and our black wire here. And I just drilled holes through here so the push button can go through after we mount this little panel back on. And there's a lot of ways you can do this. This is the button that I had, but I'll share a picture of one similar that actually comes with its own wiring harness if you'd rather just use that instead of soldering these connectors on. I'm just connecting my wires here to this temporary drive that I'm setting up. This will be going to our motor. This plugs right in. This will be our power coming in. We want to come off of our relay. And these smaller wires, even though they look tiny, they're TFE wires, so they're high current rating, and they'll be perfectly fine to quench the load across the brake. Our permanent controller will be a little bit bigger, but I think we're going to have plenty of room here. So this is just our controller power coming from the relay, normally open contact. So when it energizes, it puts power in. Now I'm just going to hook up the JST connector to our headlights around. I might actually do this a little bit neater and take this shroud off. There's a lot of just empty room there for wiring and stuff, so we'll use that for storage. It'll be kind of handy. Let's pop this back on. I'll share a little bit of footage later about some of the soldering I did to get these JSTs on there, maybe up in one of the corners here, so it don't take up so much video time. And I'll share a diagram at the end if you're interested in getting your lights working. This one's going to hook up to our 12 volts in, which I have a DC to DC converter here. And I'll just go ahead and show now little video up in the top right corner of what I did to get this little converter the way it is here to the mount. You can do it many ways, but this is just a DC to DC converter that would take up to 60 volts in, and I trimmed it down to 12 volts, and we're going to run our LEDs off of that. That's actually the power from our 12 volts from the DC to DC converter going to our switch so we can engage our lighting. And also, when the power comes right here to our DC to DC converter, the green LED will come on as well, because we have a resistor tied in so we can put 12 volts across that. So we still have plenty of room here. We just got a little bit of cable management to do, and we're getting really close already. We do have to tie in our normally closed for our brake, and we got to tie in where our coil voltage for our relay would be. And this is going to control our coil on our relay. So if our battery voltage drops below what I have set point to 44 volts, it's going to drop that relay out and only activate it if it's above. So I have notched out this cover here, drilled a hole and then just notched it out so the wiring can go in. I should have some spiral wrap to put on these wires when I get through wiring. Keep it neat, and we'll just close it down. I've already made sure that this low voltage cutout board will miss the battery when it closes. Let's just tie wrap this braking resistor back on here. That's how Ego had it from the factory, and I'm okay with that. We'll just tie wrap it back on the side of the motor bolt and get these wires out of the way so we can put our housing back on. And just like so, we should slide down, and we just got to put our screws back down to secure our housing. So this is the red coming from our start switch, our motor engaged switch from Ego. This switch is rated for high current, but we're going to use the relay now, so it's going to take a lot of load off of that original OEM switch. This wire is actually going to go to our brake. It's coming from our controller minus output, and it's going to go to the normally closed of the relay, so when it closes or it's released, it automatically quenches across the brake. So this is our wiring back from our low voltage cutout. I've marked the labels. And as you see here, the only modification I've done to this low cutout board is I've added some hot snot, some old hot glue to secure the caps and the inductor to the board, just to give it some more rigidity, as we are going to have a little bit of bouncing open and shutting the lid here. So this is more for video. This lid, when you go to put it on, it stops at less than 90 degrees, so it falls back down. So I'm going to take this and cut this at about a 45-degree angle like so, and that should allow this lid to hinge back and hopefully stay back out of the way for the video. By the way, this rod has a groove in it, so when you push it through, I'll have to take that little cover back off. A little E-clip holds that rod from sliding back out, so I will put that on at a later time. But just so you know, if you take yours out, you do have to have that clip removed from that groove for it to slide out. I'm just going to tie in our low voltage cutout. I have a plus in and a minus in, and then I just have a plus out. So we just need to monitor our voltage on our battery level and then output based on that. And that's what's going to pull in the coil on our relay to activate the mower. Just going to do a little bit of wiring management here. Just keep it up out of the way. I'm also using these lever nuts made by Wago, and they're rated for over 25 amps, and they've been tested well above that. But if you wanted to do something more permanent or terminal strip, I understand. I'm just going to plug my potentiometer up here and we can slide our cover on. Snap our side panel back on. Insert the battery. Let's see if we can give it a try here. There we go. Awesome. Speed regulation works. Our low voltage cutout showing. The brake works. Awesome. Yep, fires back up. Our green light and just now indicates the mower's having power to come on, of course. Ooh, our headlights work. Nice. See what the button looks like here. And you push it. I already had this blue one. A green one will be even better. Yeah. Headlights looking good. So back now with this mower out the next day ready to test. I'm going to cut the speed up around halfway. That's down all the way up halfway just for playing here. I still got to get me some wrap for this. The spiral wrap I have is too big. I'll get some small wrap. Get my battery in. All we have now is our start button. Which is really only helpful for direction check on the blade. We can cut this on up. We'll release and we use our relay to do our braking now. So we've already had the bypass switch when we bought it for the handle folding. I chose in this instance not to use my switch for the extend because I personally don't care whether this is extended or not. It's not going to hurt me, so. Anything you do, of course, you do at your own risk, and it's all up to you how you do yours. I chose to leave mine with this main safety for the start. So we are now using our board for voltage monitoring before we start. And then I have this control where I can control it playing around with it until I know for sure how I want to do it. So it's very possible you just want to leave this wide open at all times, right? So if that's the case, then we'll just we'll either hot glue the knob down, which is the easiest thing here, right? Or when you're installing it, just use that JST connector and just jump your power where it's straight on max all the time. If we cut this on, our lights do work. And we get our green LED. We just turn down really low right now. So
So we do know of some shortcomings with this design, and this was all about testing, and I'll share with you in the next part of this video what I learned from it and what I would change for a better design for it. But yeah, can we get by in a tight, you know, being thrifty and keeping a good mower running with some pretty cheap and available parts? Absolutely. All this, if you choose to do so, is done at your own risk. There are risks involved with any type of equipment you're working on, modifying or making yourself, of course. But without risk, there's no fun. But of course, I'm going to be as safe as I can be with this. This is going to be my backup mower. I'm going to always store the battery out of it, which you should do with any device you have. Kept my main safety in place, and you can even leave this safety here in place, of course, as well as the fold switch if you really wanted to. I didn't have an option without buying one for mine. It was already removed here, but whatever you feel is best for your situation. And even though I don't have any graphs to really test it on right now, I'm just going to go through these leaves, just let you see it working on video, and we'll discuss some pros and cons afterwards.
So back now with our 40 amp controller. It does have a little bit of noise to the low end, but this controller seems like it might work okay. It does have a built-in pot. Let's try it one more time. Breaks well. Now back with my 50 amp controller, and I just have it temporarily mounted here to see how it fits in there, but it also has the switch on the potentiometer, and it is remote, so we could extend it all the way to the handle if we really wanted to, or we could just put it back like it was. And I am liking the sound of this one a lot better. It does fit in here quite well. I got the pot mounted back on the cover for now. Let's see how this works. It's a lot bigger, but I think this controller here is the way to go. Not 100% sure about the 48 volt rating, but really even most 48 volt lead acid systems will be charged up to like 56 volts when charging, so hopefully it's going to be fine. And one more time. Awesome. So now I just want to take a few minutes to go over the drawings, and these are just preliminary drawings that I come up with, just sharing them with you here if you're interested. The first one I want to look at is the actual power for the controller, and I'll have it up on the screen here just to share it with you, and you can modify it or whatever you would like. Hopefully you find it helpful, but I do want to share that the red wire coming off the 40 amp fuse that I showed going to the 20 amp low voltage cutout, that wire is actually not there. It's coming through from the start button, and the plus on the low voltage cutout jumps through, so that's not a separate contact like I thought when I ordered it. That's going to be fine. It's still taking load off of that start button. The startup current, when that inertia is on the load, it's actually going to be on the relay contact, so it's still helping with that delay of the low voltage cutout coming on, so that's going to help. And of course, that 30 amp controller that I showed on the bottom left here is actually going to be a 50 amp controller. That's how I'm going to end up with mine. So whichever controller you choose, I don't recommend a 30 amp because it's truly only 500 watts when you get to reading about it. So 500 watts is not enough to run this motor for long term. But that's how I tied my brake in. So yeah, other than the that one red wire showing from the fuse to the low voltage cutout, that's really the main difference of how we ended up. So you can print out that drawing and modify it however you would like. The next thing I want to talk about is a little bit about the lights. If you're interested in the lights, you can stay tuned for this part. So I decided to use that DC to DC converter, 60 volts, set down right at 12 volts. So this is going to be a very stable voltage. So I'm using a resistor to limit my current, and the calculation here is 12 volts minus the 3 volts for the green LED. So it come out to, I'm guessing, 20 milliamps to calculate with Ohm's law here. E over I times R. So we're going to be somewhere around 450 ohms calculated. So I used a 470 ohm resistor I had. You know, half watt resistor there is fine. And as I mentioned, our anode's going to the black and the cathode's actually the blue wire the Ego has connected to that tricolor LED. If you're interested in keeping it, and like I mentioned earlier in the video, you can modify it to turn different colors if you wanted to. Just adding a microcontroller and stuff to it. I want it to be straightforward. I don't want more complicated stuff. When I get ready to cut grass, I want to cut grass. So as we come on down to the illuminated push button that I added, we see it's got a contact point that I'm going over to the headlights, and I'm also using the LED built into it for just indication that they're on. From when you actually operate in the mower, you can see that it's on or off easy. The headlights there, it looked like they was at 12 volts when I tested my mower. I think 11.85 volts. So I set it at 12 volts and set it and forget it. I think they're a 2-watt headlight. So there you go. If you're interested in doing your lights like so, you can use that diagram as well or modify it however you would like. So guys, thanks so much for watching. I hope you enjoyed the video. I hope you at least found it helpful. As always, I'll have links down in the description. If you find them helpful for a project you might be doing or a similar retrofit to the Ego mower, feel free to check those out. And any link that I share there that you click on does help support the channel through affiliate links, and I greatly appreciate it. So guys, thanks so much for watching, and God bless.